The early invention of film and motion pictures, an alchemical breakthrough of biotechnology bridging art and science, written by Melissa McGrath. The evolution of photographic technology has fundamentally altered our global culture, the way we interpret and experience our reality and navigate our lives.
March of time!
At the heart of photography and film is a chemical, optical process intuited by a multitude of medieval alchemists, artists, philosophers, mathematicians, and modern scientists, establishing the world of technology and art we see today. Predating the photographic era, the perspective of art, science, and the physical world was drastically different, evolving incrementally over years of experimentation and discovery. Leagues of visionaries set the dominoes for the development of cinematic art, science, and new technology, forever transforming and shaping the cultural norms often taken for granted in the present day. The saying, "a picture's worth 1,000 words," can almost lose its original poetic timbre to someone who has immersively adapted to the norms of our modern technoculture, able to create relatively objective fixed media records of reality itself. What is written language but a thought, taken and frozen to remain its form for interpretation? This is the function of an image in photography. But what did life look like before these technological breakthroughs formed the structures of our society? Without actually traveling to a foreign continent or region, how would you imagine what the life of everyday residents looked like? What did entertainment look like? What would happen if there was no semi-objective records of the world and we had to rely purely on mental imagery? Today, fragments of our memories are often linked to pictures as bookmarks, our brains forming half-realized, half-imagined photos of what happened. Before noting some key figures in the historical development of this technological pursuit of both the arts and sciences, first, we give homage to light. The changing of bodies into light and light into bodies is very comfortable to the course of nature, which seems delighted with transmutations. Sir Isaac Newton. Sir Isaac Newton was a bridge between the scientists of old and the scientists of the New World, the last of medieval alchemists and magicians, and the first of modern scientists to unknowingly predict the science of photochemistry. Light is the key elemental force in the breakthrough of photographic and cinematic technology. Understanding its mysterious behavior in combination with the introduction of chemical properties unlocked the way we utilize and manipulate one of Earth's most innately valuable resources. It's hard to remember that the physical world is this transient, transformational lightening and darkening of three-dimensional space, full of objects. Our understanding of reality is filtered through our own biological interface, technology, the relationship and function of light as it passes through the human eye and brain. Mental imagery itself is a fixed record, with full resolution from corner to corner, yet only a semi-objective representation of reality. At best, it's an interpretive illusion based on key bits of light data through the eyes then translated by the brain. Some of the first experiments with light and aperture can be traced back to the Camera Obscura, from Latin meaning dark chamber. The Camera Obscura. Although the principles of the Camera Obscura don't constitute photography as a fixed record of a physical scene, it was through these observations of light behavior that led to the first comprehensive manipulations of light to project image. Though simple in principle, the implications of this process are foundational, the necessary precursor to modern photography and film. Using a darkroom, can, or box that doesn't allow light in, except for a single small hole on one opposite side of it, a real-life image will be projected onto the wall, but inverted, or upside down.
Through that opening, an upside-down image of the outside actually gets projected on the back of that room.
When light reflects off an object, it changes. Once it's reflected, it travels in a straight line. Mirrors were later used to revert these images, flipping them right side up. These basic principles of light passing through space are the foundation for the technology of the present. Shrinking the hole produces a sharper but dimmer image because there's less light. Wider aperture, the access holes for light, will produce a wider but generally blurrier image. This is why the lens was such an important upgrade from the hole in the Camera Obscura, because it allowed more light while maintaining a sharper image. Its convex structure gathered more light from more angles. Speculative prehistoric findings. Ancient thinkers noticed you can use this method to study a solar eclipse, suggesting possible ancient use of camera obscura as a way to observe the cosmos. Prehistoric megalithic tomb structures featuring long, narrow passageways would sometimes open into the sky and effectively operate like a camera obscura, reflecting stars and astronomical objects that were otherwise too dim to see. Although it remains speculation, perhaps the sight of a certain star could be a sign for a prehistoric people to migrate for warmer months. While it's difficult to pay homage to all the contributions of thought and development in the productions of this technology, some of the earliest written observations are credited to a Han's Chinese philosopher Mozi around 500 BCE. He spoke of a device for passing sunlight through a pinhole in plate to channel the panel of the sun, suggesting a powerful insight. In order to understand the power of light, you have to limit it. You can only understand the power of the sun and light rays by blocking out almost all of its influence. The Daguerreotype. I have captured the light and arrested its flight. The sun itself shall draw my pictures. Louis Daguerre. It wasn't just science and technology that predated these discoveries, it also relied heavily on the backs of artists. Photography didn't arise from nothing. It came on the skirts of Renaissance strides on linear perspective, intending to reimagine artistic possibilities. The early processes of photography and film development were almost alchemical, involving chemical, optical processes. Photography and film, at some point, were no more plausible than the perceived fool's errands of alchemists in their transmutation of matter. It was this type of thinking that laid the groundwork for the chemical advancements that would make this technology possible. French painter and developer of the diorama theater, Louis Daguerre, is often referred to as the father of photography for his practical photographic processes in the creation of the daguerreotype. Extrapolating on the influences of Nicephore Niepce, inventor of the heliographic plate technique, he paved some serious groundwork for today's technology. Although not trained in chemistry, it was his quest for ever-changing realism in imagery that proliferated his findings. He created panoramic paintings, diorama, and then eventually changed the game by using mercury fumes to maintain a fixed image. The maintenance of this still image was a huge breakthrough. The production of an image was possible before, but there was that missing chemical ingredient that allowed the image to remain. He used a silver-plated sheet of copper with iodine vapor, coating it with a light-sensitive silver iodine.
This process would then be repeated with fumes from bromine or quickstuff.
Then developed the image with mercury vapor and fixed it with strong salt solutions. Motion pictures. Motion pictures grew out of several streams of existing technology. The Zoetrope and Phenetoscope were some of the early tools for animating a sequence of still images. The Phenetoscope is a cardboard disc attached vertically to a handle that simulated motion, such as a person walking. The Zoetrope simulated movement by placing a strip of still images on a drum-like cylinder while it rotated. One could look through slits in its side, also giving the impression of continuous motion. Other products of similar technology would go on to present images in motion, like having to stick your head in a box to watch the sequential image. It wasn't until the mid-1890s that French Lumiere brothers, Auguste and Louis, charted the culture of inclusive cinema that we recognize today. Earlier cinematographic screenings did exist, but didn't make the mainstream breakthrough that the Lumiere brothers had, possibly due to insufficient financial backing, so they are often credited with the first screening of film to a large audience. They were also the first to really manufacture the communal culture of social entertainment and engagement that we experience today in the world of film and cinematic arts. Because of limiting technology, earlier films were usually no more than 2 minutes in playtime. The celluloid film strips would tear if the film was too long. It wasn't until the crucial invention of the Latham loop that film transformed from a technical spectacle into a mainstream entertainment medium and art form. Wheels became a groundbreaking technology in the evolution of film, as they allowed some slack to lessen the tension of the film strip to stop it from tearing. Alice Guy Blanchet. Films were not driven by narrative and plot upon their emergence, and it was credited to Alice Guy Blanchet, considered the foremost pioneer of cinema, for jump-starting this process. In 1894, she worked as a secretary for an engineer who ran a photography company, making materials for film companies like the Lumiere brothers. Through her job, she was able to attend a premiere in 1895 for the short film The Sprinkler Sprinkled. She became interested in it as an art form, and in 1896, she made a film called The Cabbage Fairy. She was said to have made this on her lunch break. This film became known as one of the earliest examples of fantasy films. She went on to direct and produce more films, eventually being made head of production at her workplace as it transitioned into a full-fledged film studio. She wrote, directed, and produced more than 1,000 movies, and was one of the first to experiment with the chronophone sound in her films, which didn't become mainstream until later in history.
There she made equally ambitious films, and we must remember this is happening all before D.W. Griffith.
Most of these films are lost, like many of this era, but you can still view The Cabbage Fairy on YouTube. Previously, her achievements were underemphasized, but in 2018, a documentary narrated by Jodie Foster called Be Natural was made in remembrance of Alice and her accomplishments and contributions to the art of cinema. Sequential imagery, the time-space-eye continuum. Film is essentially a technology that exploits a loophole in the way we process images. Cameras correspond to light in a fairly similar manner as our own eyes do. In order for us to enjoy the amazing cinema we do today, or see anything at all, there is a process, or relationship, that transpires between light, the eye, and the brain. Light is gathered and refracted through your eye, while light-sensing cells in the retina then translate that data from image to brain. It is then interpreted into the experience we call vision. Very much like the camera obscura, the images of the world we see every day are projected onto the retina in the same inverted form. It is then up to the brain to create the perception of the visual field considered right side up. Your brain creates a sensation of an image, simulating a one-to-one relationship with the outside physical world. It can be proven in a number of ways that it does not actually capture our world in a one-to-one way. Our perception is riddled with blind spots. Our brain stitches together information that makes a cohesive or fluid impression of our surroundings. The retina senses as the brain perceives, then attempts to procure a seamless interpretation of that data. A human brain can only process 10 to 12 images per second, retaining an image for a 15th of a second, and if a new one emerges, it creates the illusion of continuity. Some specific terms even exist to describe this perceptual phenomena, the brain's tendency to perceive certain types of changes in successive still images, displayed at the right speed, as still, continuous motion, such as the persistence of vision and beta motion. POV is a common optical illusion we experience when we retain an image for a short period of time, after the removal of stimuli that produced it. Beta motion is a term that describes our ability to see various types of illusory motion in successive still images. Experiments on how our brains respond perceptively to these stimuli have provided some valuable insight on the brain's role in perception. For example, images of fast-moving dots, frame by frame, will not appear as a frame of dots, but more like a snake. These findings can be observed using various demonstrations of dots. Another example uses rapidly flashing dots on different parts of a screen. If the flashes are timed and positioned correctly, we don't just perceive a dot flashing here and a dot flashing there, but we perceive a single dot that moves between the locations of the flashes, indicating that our vision is not a straightforward objective representation of reality, but more of a world of sensations stitched together in the brain, not a one-to-one representation of it. If you take this same principle but change the colors of the dots between flashes, studies show that people tend to perceive a change in the color of the dot halfway through the path it takes. How does this occur if it wasn't actually traveling and you didn't know what the second dot color would be before you saw it? It seems to indicate that not only is our vision a seemingly stitched together impression in our mind, our perception of time from moment to moment is a stimulation stitched together as well. What you think when you see 1 second can be changed a split second later. Not until after you see the green dot does it change your perception on the dot you saw halfway on its imaginary journey. Like you're seeing with your memory and other cognitive functions, vision is not reality, but more like an illusion mostly formed by reality. Not quite there in your senses, but perceived as you edit the information. Treading the terrains of imaginative thinking. Incredibly fascinating stuff. The dimensions that exist in the history of these technologies we use and enjoy today are steep. Each brick-by-brick placement of a new discovery led to the next, made by innovative people crazy enough to passionately dedicate their lives to their curious fascinations. It's both inspiring and wild to consider the obstacles most of these thinkers and inventors had to encounter over time. One of the most interesting things to me about these breakthroughs is that during the process, many of these figures in history were seen as outlandish or foolish for their relentless experimenting and digging. While these ideas kept them intrigued, procured primarily from a special type of imaginative hope and curiosity, many of them would have no clue what their research would lead to in following years to come, and if the time they spent dedicating their lives to these things would ever prove to be purposeful or yield value. And yet, despite the voices that may have slithered, assuring them that their pursuits for some imaginary hypothesis were indeed insane, they continued their experimental research. I've come to understand science and art as the belief that we can comprehend the truth. Often, both then and now, those who pledge to prove complex theories engage in such a courageous commitment to their ideas and imagination that others may see them as strange, perhaps disturbingly obsessed with their work. With no clear path of utility ahead, what if those in our history allowed such judgments, both externally and psychologically, to undermine their efforts? What would have been if such weight has steered them from this belief? The oddly twinkling belief that the comprehension of a truth that was not yet proven, known, discovered, or even possible. What separates these people from those who give up before making the leap onto the abyss of innovation? What if Einstein, for example, when unfairly criticized, deeply internalized these negative thoughts? What would have become of science today had he lost his unfettering will and tossed his work into the chamber of flame, charring his brilliant scribbles to rid the pressures of his mind? Surely this would have drastically halted the evolutionary process of our science, art, and technological progress. We absolutely need these risk takers, these pioneers of perseverance, who seem to harbor the mysterious courage to continue past the mountains of doubt and failure, the ones that sizzle with desire to create, invent, envision, philosophize, and experiment.
We ask your help in this fateful moment as sign that we scientists do not stand alone.
Perhaps they are the Earth's forces at play, willing growth and evolution through some indistinguishable passion, to break the world apart and piece it back together anew. If you or someone you know has this burning fire in them, refuse the impulse to smother it. Deeply encourage yourself or a friend to feed it as long as they can. It seems to me that the world of technology, art, science, and culture informs one another seamlessly, like one continuous motion of collaborative construction. Or maybe that's just my brain doing its thing.
Without such freedom, there would have been no Shakespeare, no Goethe, no Newton, no Faraday, no Pasteur, and no Lister.